Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that AB equals to 4 units, CD equals to 2 units. We also know that CB equals to AD. Angle ABC, this angle equals to 90 degrees. Angle DAB, this angle equals to 30 degrees. And we want to find out the area of quadrilateral ABCD. So we will start with the first method. In the first method, we will draw perpendicular from point D to AB. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we will define the touching point of the perpendicular from point D to AB as point E. And we will define line segment DE, this line segment as A, that is to say DE equals to A units in its length. And then we will focus on triangle ADE. And triangle ADE sinus 30 degrees equals to DE over AD. I will repeat again. In triangle ADE, in this triangle, sinus 30 degrees equals to DE over AD. But DE equals to A units according to our definition, so we can substitute DE by A. So it is A over AD. We also know that sinus 30 degrees equals to 1 over 2. So 1 over 2 equals to A over AD. Here we will cross multiply equation number 1, and we will get that AD equals to 2 times A. AD equals to 2A. So we can write here that AD equals to 2A. But we know that AD equals to BC according to what is given us in the question. AD equals to CB according to what is given us in the question, and we found out that AD equals to 2A. So from this equation we will derive that CB also equals to 2A. So here we can write down that CB equals to 2A in the next step. We will draw perpendicular from point D to CB. So this angle will be a right angle, it equals to 90 degrees, and this angle will be also a right angle, that is to say it will be equal to 90 degrees, and we will define the touching point between the perpendicular from point D to CB as point F. We will focus on quadrilateral DFBE. In quadrilateral DFBE, we have three right angles, 1, 2, 3. The sum of three right angles is 90 degrees times 3 is 270 degrees. Plus, we define the fourth angle as angle X. And the fourth angle equals to X. And we have actually rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So I will read again rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees, and especially in quadrilateral DFBE, the sum of its angles must be equal to 360 degrees. That is to say, 270 degrees plus the size of angle X must be equal to 360 degrees. According to rule number 1, Here we will subtract 270 degrees from this equation, and we will get that the value of angle x will be equal to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that the value of angle x is equal to 90 degrees. That is to say it is a right angle. So we can substitute x by a right angle. So you can see from the drawing that all four angles inside quadrilateral ADFB, inside quadrilateral EDFB, they are all equal to 90 degrees. And we also have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So actually, if not a square, so it must be at least a rectangle. I will read rule number 2 again. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So therefore, according to rule number 2, quadrilateral DFEB is a rectangle. Quadrilateral DFEB is a rectangle according to rule number 2. So we will relate to quadrilateral DFBE as a rectangle, and we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So I will read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. Therefore, the opposite sides of rectangle DEFB are equal to each other. That is to say, DE equals to FB. DE equals to FB in rectangle DE FB. DE equals to FB according to rule number 3. DE equals to FB, but according to our definition, DE equals to A. DE equals to A. From this equation, we will derive that FB also equals to A. FB equals to A units in its length. Here FB equals to A. And what is the value of CF? From the drawing you can see easily that CF equals to CB minus FB. I repeat again, CF equals to CB minus FB. You can see it easily from the drawing. That is to say, CF equals to CB, but CB equals to 2A. And we already found out that FB equals to A. So CF equals to 2A minus A is A. So we found out that CF equals to A. So we can write here that CF equals to A. In the next step, we will join points D and B together by a straight line. And we will prove the triangle DFC is congruent to triangle DFB. I'll repeat again. We will prove that this triangle DFC is congruent to this triangle DBF. So why those two triangles can go into each other? First of all, we know that CF equals to FB. They are both equal to A units, so CF equals to FB, and they are both equal to A units. I'll repeat again. CF equals to FB, and they are both equal to A units in their lengths. Those two angles, they are both right angles, that is to say they are equal to 90 degrees, therefore they are equal to each other. So angle DFC, this angle, is equal to this angle DFB. And they are both equal to 90 degrees. I'll repeat again. Angle DFC equals to angle DFB, and they are both equal to 90 degrees. And side DF, this side is a common side, it belongs to both triangles, so DF equals to itself. You can write down that DF equals to DF as a common side that belongs to both triangles. So DF equals to DF is a common side that belongs to both triangles. Therefore, we actually proved that this triangle DFC, congruent to this triangle DFB, this is the sign of congruent. Triangle DFC congruent to triangle DFB according to side angle side rule. I will repeat again. We actually proved the triangle DFC congruent to triangle DFB according to side angle side rule. So, what is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between them and the angle that is located between those two sides in one triangle congruent to two sides and the angle that is located between those two sides in another triangle, then you prove that those two triangles can go into each other according to side angle side rule. And we actually proved that those two sides and the angle that located between those two sides in triangle DFB can go to those two sides and the angle that is located between those two sides in triangle DFC. Therefore, we proved that those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to DB. DC equals to DB. DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say DC and DB, will be equal to each other. But according to what is given us in the question, DC equals to 2 units. It is given us the question that DC equals to 2 units. So we can write here that DC equals to 2 units, and from this equation we will derive that DB also equal to 2 units. DB equals to 2 units. So we can write here that DB equals to 2 units. So in the next step, I will present to you a new law that is actually the law of cosines. According to the law of cosines, first of all, the law of cosines is true in any triangle. The law of cosines so you can write down that in any triangle, you can use the rule in any triangle, the law in any triangle. In any triangle, so if we have triangle ABC, that could be any triangle, so this is triangle ABC. And we know that the length of side AB is A units is equal to A units in its length. The length of side BC is B units. And the length of side AC is C units. And we also know that the angle between AB and BC is angle theta. Then, according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Again, A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we will subtract C squared and we will add 2AB cosine theta to this equation, and we will get that A squared plus B squared minus C squared equals to 2 times AB cosine theta. Here we will divide this equation by 2 times AB, and we will get that cosine theta is equal to A squared plus B squared minus C squared over 2 times AB. I will repeat again, we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. And we can implement the law of cosines in our triangle ADB. So if we focus on triangle ADB, in triangle ADB, we will get that cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. So we actually implemented the law of cosines in triangle ADB, and we got that cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A over 4. We know that cosine 30 degrees is square root of 3 over 2, so I'll write it down. So we get that square root of 3 over 2 equals to 2A squared is 4A squared plus 4 squared is 16 and minus 2 squared is minus 4, so 16 minus 4 is 12. And in the denominator we have 2 times 4 is 8 and 8 times 2A is 16A. Here we will multiply this equation by 16A and we will get that square root of 3 over 2 times 16A equals to 4A squared plus 12. 16 over 2 is 8. So we will get that 8 times square root of 3a equals to 4a squared plus 12. Here we will divide this equation by 4. 8 over 4 is 2, so we will get that 2 times square root of 3 times a equals to 4 over 4 is 1, so we get here a squared plus 12 over 4 is 3. We will subtract 2 times square root of 3a from this equation, and we will get that a squared plus 3 minus 2 times a times square root of 3 equals to 0. We know that 3 is square root of 3 squared, so we'll substitute 3 by square root of 3 squared, and we'll get that a squared plus square root of 3 squared, that is 3, minus 2 times a times square root of 3 equals to 0. As you can see, this equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific equation, a equals to a and b equals to square root of 3 units. So we will get, according to this algebraic identity, that this expression equals to a minus b squared. That is to say, a is a and b is minus 3 squared, so we get that it equals to a minus square root of 3 squared, and it equals to 0. So here we will take a root out of this equation, and we will get that a minus square root of 3 equals to 0. Here we will add square root of 3 to this equation, and we will get that a equals to square root of 3 units. So we found out that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units. A equals to square root of 3 units, and also here a equals to square root of 3 units. In the next step, we will focus on triangle D, the right triangle, triangle DEB. On the right triangle, triangle DEB, according to the Pythagoras theorem, DE squared plus EB squared must be equal to DB squared. I'll repeat again. On the right triangle DEB, according to the Pythagoras theorem, DE square equals to EB square, DE square plus EB square equals to DB square. So according to equation number 1, DE equals to square root of 3, therefore DE square is square root of 3 square, square root of 3 square is 3, and it equals to EB square. EB is the missing variable, so we will leave it as it is, plus dB square. We know that dB equals to 2 units, therefore dB square is 2 square. 2 square is 4. So in conclusion, we got that according to equation number 1, 3 equals to EB square plus 4. Here we will subtract from this equation number 1, 3, and we will get that according to equation number 1, EB square equals to 4 minus 3 is 1. Here we take a root out of this equation number 1, and we get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1 unit. Here we can write down that EB equals to 1 unit. But according to the rule that the opposite sides of a rectangle are equal to each other, we will get that EB equals to DF. But EB equals to 1 unit, therefore DF will be also equal to 1 unit. That is to say, those two sides are both equal to each other, they are both equal to 1 unit because of the fact that the opposite sides of a rectangle are equal to each other. And what is the value of AE? The value of AE equals to AB minus BE. Again, AB minus BE equals to AE. It is very simple to see it from the drawing. So we can write down that AB minus BE equals to AE. Again, AE equals to AB minus EB. So AE equals to AB is 4 units. And we have already found out just right now that EB equals to 1. So AE equals to 4 minus 1 is 3. So we found out that AE equals to 3 units. So we can write here that AE equals to 3 units. So what is the area of quadrilateral ABCD? The area of quadrilateral ABCD here the squared brackets is the sign for the area. This means the area of triangle the area of quadrilateral ABCD will be equal to the area of triangle ADE, the area of the right triangle ADE, plus the area of rectangle DFEB plus the area of the right triangle DCF. Okay, the area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle DFBE plus the area of triangle DCF. So the area of the right triangle, triangle ADE, this triangle, equals to the base of the triangle that is AE times the height to the base that is DE over 2. I repeat again, the area of the right triangle, triangle ADE, equals to the base of the triangle that is AE times the height to the base that is DE over 2. And the area of rectangle DEBF will be equal to EB times ED. EB times ED and the area of the right triangle, triangle DCF will be equal to the base of the triangle that is DF times the height to the base that is CF over 2. Okay, I repeat again, the area of the right triangle, triangle DCF equals to the base of the triangle that is DF times the height to the base that is CF over 2. Okay, so the area of triangle ADE equals to AE is equal to 3 units times DE equals to square root of 3 units over 2. So we found out that the area of the right triangle, triangle ADE equals to square root of 3 times 3 over 2, and the area of the rectangle DFBE will be equal to EB, that is actually 1, times FB, that is actually square root of 3 units, or ED, this is also square root of 3 units. So we found out that the area of rectangle DFBE equals to square root of 3 units plus the area of triangle DCF, the area of this triangle, triangle DCF, that is actually equals to DF equals to 1 plus CF equals to the square root of 3 units over 2. So we found out that the area of square ABCD equals to the sum of those 3 expressions. This is the area of square ABCD, and the area of quadrilateral ABCD equals to the sum of these 3 expressions. Here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with those 2 expressions. And we will get that the area of quadrilateral ABCD is equal to, here we take square root of 3 as a common factor, and we will get, here we have 3, here we have 2, and here we have 1, all divided by 2. So we get square root of 3. 1 plus 2 is 3, and 3 plus 3 is 6. 6 over 2 is 3. 3 times square root of 3. So we got that the area of quadrilateral ABCD, according to the first method, it equals to 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. I'll repeat again. We found out that the area of quadrilateral ABCD equals to either 3 times 3 square units, or in terms of numbers, it equals to 5.196 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of quadrilateral ABCD according to the second method. In the second method, we will do another construction. From point A, we will go perpendicular to AB. So this angle is a right angle, that is to say it equals to 90 degrees. This is a right angle because we do perpendicular from point A to AB. So this is a right angle. From point C, we will draw perpendicular to BC. So this is a right angle, that is to say it equals to 90 degrees. We will define the intersection point between the perpendicular from point A to the perpendicular from point C as point E. The intersection point between the perpendicular from point A to the perpendicular from point C is defined as point E. So we have here quadrilateral ABCE. In quadrilateral ABCE, we have 3 right angles, 1, 2, 3, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle that we will define as angle X. We will define this angle as angle X. Must be equal to 360 degrees according to rule number 1. I will repeat again. In quadrilateral ABCE, the sum of the angles is equal to 360 degrees. That is to say, the sum of 3 angles, the sum of its 3 angles, that is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees according to rule number 1. We will subtract 270 degrees from this equation, and we will get that the value of angle X, it is actually equal to 360 degrees minus 270 degrees is equal to 90 degrees. So we found out that the value of angle X is equal to 90 degrees. That is to say, it is a right angle, so we can substitute angle X by a right angle. So actually in quadrilateral ABCE, we have 4 right angles, and according to rule number 2, quadrilateral ABCE is a rectangle. So I write it down that quadrilateral ABCE is a rectangle according to rule number 2. And we also have rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle ABCE, AB equals to EC, AB equals to EC, according to the rule that the opposite sides of a rectangle are equal to each other. But it is given us the question that AB, this is according to rule number 3, it is given us the question that AB equals to 4 units. From this equation we will derive that CE also equals to 4 units. CE equals to 4 units. So we can write here that CE equals to 4 units. And if we define CB as X, according to rule number 3, the opposite sides CB and AE must be equal to each other in rectangle ABCE. So CB equals to AE, CB equals to AE, according to rule number 3 that the opposite sides of a rectangle are equal to each other. But according to our definition, CB equals to X. CB equals to X, and from this equation we will derive that AE also equals to X. AE equals to X. Here AE equals to X. But it is also given us in the question that AD equals to CB. AD equals to CB. And CB equals to X, so AD must be also equal to X. In the next step, we will join points E and D together by a straight line. And we will also join together points D and B by a straight line. We will focus on triangle AED. I will draw triangle AED in a new page and we will analyze triangle AED. Okay? So triangle AED. Before that, we know that angle DAB equals to 30 degrees, and we found out this angle equals to 90 degrees. Angle EAB equals to 90 degrees. So 90 degrees minus 30 degrees will be the value of this angle that is actually angle EAD. So angle EAD equals to 60 degrees. So I draw triangle EAD in a new page. In triangle EAD, we have two sides that are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles must be also equal to each other because they are located in front the equal sides AC, AE and AD. So if we define this angle as y, then this angle must be also equal to y. In triangle AD, the sum of the angles must be equal to 180 degrees. What does it mean? It means that y plus y plus this angle that equals to 60 degrees must be equal to 180 degrees. Y plus y is 2y plus 60 degrees must be equal to 180 degrees. Here we will subtract from this equation 60 degrees and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We will divide this equation by 2 and we will get that angle y equals to 60 degrees. So we found out that angle y equals to 60 degrees, so we can substitute y by 60 degrees. Here also y equals to 60 degrees. So actually we found out that triangle AED is an equilateral triangle. Equilateral triangle because all of its angles are equal to 60 degrees, and we know that in any equilateral triangle all the sides of the equilateral triangle are equal to each other, so ED must be also equal to x. So in our original drawing we can write down that ED equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees, and the angle AEC, we found out that angle AEC equals to 90 degrees. Angle AED equals to 60 degrees. So 90 degrees minus 60 degrees is the value of this angle, that is actually angle DEC. 90 degrees minus 60 degrees is 30 degrees. So we found out that the value of angle DEC is equal to 30 degrees. In the next step, we will prove that triangle ADB is congruent to triangle EDC. I write it down. We will prove that triangle ADB, this triangle, is congruent to triangle EDC, this triangle. So why those two triangles can go into each other? First of all, we know that EC equals to AB, EC equals to AB, and both those two sides are equal to 4 units. So here EC equals to AB equals to 4 units. We also know that those two angles, they are also equal to each other. They are both equal to 30 degrees. So angle CED is equal to angle BAD, and they are both equal to 30 degrees. equals to AD equals to X. ED equals to AD equals to X. So actually we found out that triangle ADB can go into triangle ADC according to side angle side rule. I write it down. We actually proved that triangle ADB can go into to triangle EDC according to side angle side rule. I will not repeat all the explanation of side angle side rule because we did it in the first method. From the fact that those two triangles can go into each other, we will conclude that CD equals to DB, CD equals to DB, CD equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say CD and DB, must be also equal to each other. But according to what is given us in the question, CD equals to 2 units, CD equals to 2 units, and from this equation we will derive that DB also equals to 2 units. Okay, and in the next step we will implement the law of cosines in triangle ADB. Okay, so I will draw triangle ADB in a new page, and we will implement the law of cosines in triangle ADB. So triangle ADB So I draw triangle ADB in a new page. We will implement the law of cosines in triangle ADB according to the law of cosines. Cosine 30 degrees will be equal to x squared plus 4 squared minus 2 squared over 2 times x times 4. And we know that cosine 30 degrees is square root of 3 over 2. Square root of 3 over 2. And it equals to x squared plus 4 squared is 16. Minus 2 squared is minus 4. 16 minus 4 is 12. And in the numerator we have 2 times 4 is 8. And 8 times x is 8x. Here we will multiply this equation by 8x, and we'll get that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4. So in conclusion, we will get that 4 times square root of 3x equals to x squared plus 12. We will subtract 4 times square root of 3x from this equation, and we will get that x squared plus 12 minus 4 times square root of 3x equals to 0. We know that x squared, that 12 is actually 2 times square root of 3 squared, so we substitute 12 by 2 times square root of 3 squared, plus here we will substitute 4 by 2 times 2, so it is minus 2 times x times 2 times square root of 3, that equals to 0. So here, this equation is very similar to the algebraic identity that states that x squared, that a squared plus b squared minus 2 times ab equals to a minus b squared, and it equals to 0. In our specific expression, a equals to x, and b equals to 2 times square root of 3 I repeat again, in our specific expression, a equals to x and b equals to 2 times square root of 3. So a minus b squared will be equal to a is x, so it is x minus 2 times square root of 3 squared equals to 0. Here we'll take a root out of this equation and we will get that x minus 2 times square root of 3 equals to 0. Here we will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So we found out that x equals to 2 times square root of 3 units. Here x equals to 2 times square root of 3 units, x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. So here, what is the area of square ABCD? The area of quadrilateral ABCD will be equal to the area of triangle ADB, the area of this triangle, triangle ADB, plus the area of triangle BDC, this triangle. I will repeat again. The area of quadrilateral ABCD composed of 2 triangles, therefore the area of triangle of quadrilateral ABCD will be the sum of the areas of the 2 triangles that it composed of. It consists of 2 triangles, so the area of the 2 the sum of the areas of the two triangles will be equal to the area of quadrilateral ABCD. Here we will draw perpendicular from point D to AB. We will define the touching point between the perpendicular from point D to AB as point S. We will define line segment DS as edge. This is the height to the base AB. In triangle ADS, we know that sinus 30 degrees equals to edge over 2 times square root of 3. Again, in triangle ADS, sinus 30 degrees equals to edge over 2 times square root of 3. Sinus 30 degrees is 1 over 2, so I'll write it down. We get that 1 over 2 equals to edge over 2 times square root of 3. Here we will multiply this equation by 2 times square root of 3. 2 times square root of 3 over 2 equals to h. 2 over 2 is 1, so we found out that h equals to square root of 3. So we can write down that h equals to square root of 3 units. And so what is the area of triangle ADB? The area of triangle ADB will be equal to the base of the triangle, that is AB, times the height to the base, that is h, over 2. Again, the area of triangle ADB equals to AB times the height to the base, that is h, over 2. AB equals to 4, and h equals to square root of 3 units, all divided by 2. So here 4 over 2 is 2. So we found out that the area of triangle ADB equals to 2 times square root of 3 units. And the only thing that is left to do is to find out the area of triangle DBC. And the area of triangle DBC we will do it according to a special formula. First of all, we will find out the semi-perimeter of triangle DBC. The semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. Here we'll define it as A. This is B. And this is C. So the semi-perimeter of triangle DBC, that is actually S, the abbreviation for semi-perimeter, S will be equal to A plus B plus C over 2. A plus B plus C over 2. Again, the semi-perimeter of triangle DBC equals to A plus B plus C over 2. So the semi-perimeter of triangle DBC is A is 2, plus B is also 2, plus C is 2 times square root of 3, all divided by 2. So the semi-perimeter of triangle DBC, S equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2, 4 over 2 is 2, plus 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle DBC is equal to 2 plus square root of 3 units. And then the area of triangle DBC, we will find it according to a special formula. The area of triangle DBC will be equal to the square root of S times S minus A times S minus B times S minus C. We know that A equals to 2, B equals to 2, and C equals to 2 times square root of 3. And we already found out that S equals to 2 plus square root of 3 units. So we will put all the data inside this equation, and we will get that the area of triangle DBC will be equal to the square root of S is 2 plus square root of 2, 2 plus square root of 2. S minus A is 2 plus square root of 3 minus 2 is square root of 3. S minus B is the same because B equals to 2, so it is also square root of 3. And S minus C is 2 plus square root of 3 minus 2 square root of 3. That is actually 2 minus square root of 3. And it equals to square root of 3 times square root of 3 is 3. And 2 plus square root of 3 times 2 minus square root of 3, we'll use the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A is 2 and B is square root of 3, so A squared is 2 squared, 2 squared is 4, minus B squared, B is square root of 3, square root of 3 squared is 3. So in conclusion we got that the area of triangle DBC is equal to square root of 3, 4 minus 3 is 1, and 3 times 1 is 3, so the area of triangle DBC equals to square root of 3 square units. And we have already found out that the area of triangle ADB is equal to 2 times square root of 3 units, and the area of quadrilateral ABCD is composed of 2 triangles, and the sum of the 2 triangles will be equal to the area of quadrilateral ABCD. It's composed of triangle DBC, and it's also composed of triangle ADB. So the area of quadrilateral ABCD equals to the area of triangle DBC, that is square root of 3 units, plus the area of triangle ADB, that is 2 times square root of 3 units, 1 times square root of 3 units plus 2 times square root of 3 units, it equals to 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. I repeat again, we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, in the next step, I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ABCD. We found the area of quadrilateral ABCD in two different methods. In the first method, we did construction from point D, we draw perpendicular to AB. So this angle equals to 90 degrees and this angle also equals to 90 degrees. In triangle ADE, we know that sine 30 degrees equals to DE over DA, and we define DE as A. In triangle ADE, sine 30 degrees equals to DE over AD, and we know that DE equals to A according to our definition. So sine 30 degrees equals to A over AD. Sine 30 degrees is 1 over 2, so we got that 1 over 2 equals to A over AD. We cross multiply the equation number 1, and we got that, actually we multiply the equation number 1 by AD, and, okay, and also, so we got that AD equals to 2A. We found out that AD equals to 2A, so we can write here that AD equals to 2A. But because of the fact that, according to what is given us in the question, AD equals to BC and AD equals to 2A, so BC will be also equal to 2A. And what is the value? Okay, so CB equals to 2A. And then we draw perpendicular from point D to CB, so this angle equals to 90 degrees and this angle equals to 90 degrees. In quadrilateral DFBC, we have three right angles, 1, 2, 3, and the sum of three right angles is 270 degrees, plus this angle that we define as angle X. According to rule number 1, that the sum of the angles in any quadrilateral is equal to 360 degrees, we will get that 270 degrees plus angle X must be equal to 360 degrees. We subtract that 270 degrees from this equation, and we got that angle X equals to 90 degrees. Angle X equals to 90 degrees. This angle equals to 90 degrees. Therefore, quadrilateral DFBEB has four right angles. And we have rule number 2 that states that any quadrilateral that has four right angles must be at least a rectangle, so we will relate to quadrilateral DEFB as a rectangle, and we have rule number 3 that says that the opposite sides of a rectangle are equal to each other. So in rectangle DEFB we will get that DE equals to FB according to rule number 3. D equals to FB, what according to our definition, D equals to A, so from this equation we will derive that FB also equals to A. FB also equals to A. And what is the value of CF? CF equals to CB minus FB. CF equals to CB minus FB. CB is 2A. And FB is A, so CF equals to 2A minus A, 2A minus A is A. So we found out that CF equals to A units. Then we proved that triangle DFC is congruent to triangle DFB. Triangle DFC is congruent to triangle DFD. Why those two triangles congruent to each other? First of all, we know that CF equals to BF equals to A. CF equals to BF equals to A. Those two angles are right angles, they are therefore they are equal to each other, so angle DFC equals to angle DFB equals to 90 degrees. And DF is a common side, it belongs to both triangles, so DF equals to itself, DF equals to DF. So we found out that triangle DFC can go into triangle DFB according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to DB. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say DC and DB, must be also equal to each other. But DC equals to 2 units. It is given us the equation that DC equals to 2 units. From this equation, we will conclude that DB also equals to 2 units. So we found out that DB equals to 2 units. Then we implemented the law of cosines in our triangle DAB. Actually, first of all, I presented to you the law of cosines. According to the law of cosines, that is true in any triangle. If we have triangle ABC, that it could be any triangle. In triangle ABC, you can say that A squared plus B squared minus 2 times AB cosine theta equals to C squared. Here we subtracted C squared and added 2 times AB cosine theta to this equation, and we got that A squared plus B squared minus C squared equals to 2 times AB cosine theta. We divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. We implemented the law of cosines in our triangle. We implemented the law of cosines in our triangle ADB. In triangle ADB, cosine 30 degrees equals to 2A squared plus 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. Okay? And we know that cosine 30 degrees is square root of 3 over 2. 2A squared is 4A squared. 4 squared is 16. 2 squared is 4. So 16 minus 4 is 12. So in the numerator we have 4A squared plus 12, and in the denominator we have 2 times 4 is 8. 8 times 2A is 16A. In the denominator we have 16A. We multiplied this equation by 16A, and we got the square root of 3 over 2 times 16A equals to 4A squared plus 12. 16 over 2 is 8, so in this side of the equation we have 8 times square root of 3A equals to 4A squared plus 12. We divided this equation by 4, and we got that 4 over 8 is 2, so here we will have 2 times square root of 3 times A. 4 over 4 is 1, so here we will have A squared, and 12 over 4 is 3. We subtracted 2 times square root of A from this equation, and we got that A squared plus 3 minus 2 times 8 times square root of 3 equals to 0. Here we substituted 3 by square root of 3 square, and we got that A squared plus square root of 3 square minus 2 times A times square root of 3 equals to 0. This equation is very similar to the algebraic identity that states that A squared plus B squared minus 2AB equals to A minus B squared, that equals to 0. So here we can substitute this expression by A minus B squared according to this algebraic identity. In our specific expression, we know that A equals to A and B equals to square root of 3 units. So A minus B will be also equal, will be actually equal to A minus 3 square root of 3 square that equals to 0. We took a root out of this equation and we got that a minus square root of 3 square equals to 0. We added square root of 3 to this equation and we got that a equals to square root of 3 units. So we found out that a equals to square root of 3 units. Here a equals to square root of 3 units. And then we can find out the area of quadrilateral ABCD, the area, and but before that we implemented the law, the Pythagoras theorem in triangle, the right triangle, triangle DEB. In the right triangle, triangle DEB, according to the Pythagoras theorem, DE square plus EB square equals to DB square. DE square, DE equals to square root of 3. So square root of 3 square is 3, and EB square is the missing variable, plus DB square, that equals to DB square. DB is 2, so DB square is 2 square, 2 square is 4. So that according to equation number 1, 3 equals to EB square plus 4. We subtracted 3 from this equation, equation number 1, and we got that EB square equals to 1. We took a root out of this equation, equation number 1, and we got that EB equals to the square root of 1. The square root of 1 is 1, so we found out that EB equals to 1. EB equals to 1. But according to rule number 3, that the opposite sides of a rectangle are equal to each other, if EB equals to 1, then DF must be also equal to 1. And what is the value of AE? AE equals to AB minus EB. A equals to AB minus EB. So A equals to AB, that is 4, minus EB, that is 1. That is to say AB equals to 4 minus 1. 4 minus 1 is 3, so we found out that AE equals to 3 units. Now we can easily find out the area of quadrilateral ABDF, because the area of quadrilateral ABDF will be equal to the area of triangle ADE plus the area of rectangle DEBF plus the area of the right triangle, triangle DFC. Okay, the area of quadrilateral ABCD equals to the area of triangle ADE plus the area of triangle PFBE plus the area of triangle DCF. And the area of triangle ADE, first of all, we draw perpendicular from point D to AB. We define the touching point as point E. In triangle DAE, we know that sinus 30 degrees. So here we actually know that D equals to A, that is square root of 3 units. So the area of triangle ADE, the right triangle, triangle ADE, will be equal to the base of triangle ADE, that is AE, times the height, that is DE, over 2. So the area of triangle ADE equals to the base of the triangle, that is AE, times the height, that is DE, over 2. So we know that AE equals to 3 units and D equals to square root of 3. So the area of triangle ADB will be equal to 3 times square root of 3 over 2. And the area of rectangle ADEFB will be equal to EB times DE. EB is 1 and DE is square root of 3. EB times DE, EB is 1 and DE is square root of 3. So the area of rectangle ABDF will be equal to square root of 3 square units, and the area of triangle CDF will be equal to DF, that is the base, times FC, that is the height, over 2. DF times CF over 2. DF equals to 1. CF equals to square root of 3 over 2. So here we multiplied square root of 3 by 2, and then we divided it by 2 in order to have a common factor with those two expressions. And here we took a common factor of square root of 3 from the denominator of these three expressions. So inside the brackets, from here we will have 3, from here this expression we will have 2, and from this expression we will have 1, all divided by 2. So the area of quadrilateral ABCD equals to square root of 3 times 3 plus 2 is 5, 5 plus 1 is 6. So it will be equal to square root of 3 times 6 over 2. 6 over 2 is 3, so the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So we finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD according to the second method. In the second method, we actually did another construction. From point A, we drew perpendicular to AB, so this angle equals to 90 degrees. And from point C, we drew perpendicular to CB, so this angle will be equal to 90 degrees. And we defined the intersection point from the perpendicular from A and the perpendicular from C as point E. And then here we created quadrilateral ABCE that has 3 right angles. 1, 2, 3, and the sum of 3 right angles is 270 degrees. Plus the size of the fourth angle that is defined as x must be equal to 360 degrees according to rule number 1. In triangle ABCE, 270 degrees plus x must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle x equals to 90 degrees. So angle x is a right angle. So quadrilateral ABCE has 4 right angles. Therefore, we can relate to quadrilateral ABCE as a rectangle according to rule number 2. Quadrilateral ABCE is a rectangle. And we have rule number 4 that says that the opposite sides of a rectangle are equal to each other. That is to say, AB equals to CE. AB equals to CE. But according to what is given us the question, AB equals to 4. From this equation, we will derive that CE also equals to 4. Likewise, we know that CB equals to EA. CB equals to AE according to rule number 3. And if we define CB as x, then from this equation, we will get that AE also equals to x. So here CB equals to x and EA also equals to x. But because of the fact that AD equals to CB and CB equals to x, then AD must be also equal to x. Then I draw, and here we have right angle, and this angle equals to 30 degrees. So 90 degrees minus 30 degrees will be the value of this angle, that is actually angle EAD, that is to say, angle EAD will be equal to 60 degrees. So I draw triangle ADE in a new page, and we analyze triangle AD. This is triangle AD. We know that angle EAD equals to 60 degrees, and we also know that those two sides, they are equal to each other, they are both equal to x. According to the rule that in front of equal sides in the triangle there are equal angles, it means that those two angles that are located in front, the equal sides AE and AD, must be also equal to each other. So if this angle is y, this angle will be also equal to y. So those two angles, they are both equal to y, and we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, y plus 60 degrees in triangle ADE must be equal to 180 degrees. Y is 2y, 2y plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equation and we got that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We divided this equation by 2 and we got that angle y equals to 180 degrees over 2 is 60 degrees. So those two angles are both equal to 60 degrees. Therefore, triangle ADE is an equilateral triangle. That is to say, all of its sides are equal to each other, so this side is also equal to x, and all of its angles are equal to 60 degrees. So in the original drawing, we can also write down that this side equals to x, this angle equals to 60 degrees, and this angle equals to 60 degrees. But here, we know that angle AEC equals to 90 degrees. So here 90 degrees minus 60 degrees will be the value of this angle. This angle equals to 60 degrees minus 90 degrees, so actually angle DEC will be equal to 90 degrees minus 60 degrees is 30 degrees. So this angle equals to 30 degrees. Then we proved that those two triangles can go into each other. Why? Those two triangles, so we proved that triangle ADB can go into triangle DEC. Why those two triangles can go into each other? First of all, we know that EC equals to AB equals to 4 units. EC equals to AB equals to 4 units. Those two angles, they are equal to each other, they are both equal to 30 degrees. Angle CED equals to angle BAD equals to 30 degrees. And ED equals to AD equals to X, ED equals to AD equals to X. So we actually proved that triangle ADB can go into triangle ADC according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that CD equals to BD. CD equals to BD. But CD equals to 2 units, according to what is given as the equation. From this equation, we will derive that BD also equals to 2 units. BD equals to 2 units. Then we implemented the law of cosines on triangle ADB. So I actually draw triangle ADB in a new page, and we implemented the law of cosines on this triangle ADB. According to the law of cosines in triangle ADB, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. Okay, and cosine 30 degrees equals to square root of 3 over 2, and it equals to x squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12. So in the numerator we have x squared plus 12, and in the denominator we have 2 times 4 is 8, so 8 times x is 8x, so in the denominator we have 8x. We multiplied this equation by 8x, and we got that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so we got here 4 times square root of 3x equals to x squared plus 12. So we subtracted 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. Here we know that 12 is equals to 2 times square root of 3 squared, so we can substitute 12 by 2 times square root of 3 squared, and we get that x squared plus 2 times square root of 3 squared minus, and we will substitute 4 by 2 times 2, so here we get that it is minus 2x times 2 times square root of 3, and this expression, it is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. Here a is equals to x and b equals to 2 times square root of 3. a equals to x and b equals to 2 times square root of 3. So a minus b square will be equal to x minus 2 times square root of 3 square. That equals to 0. We took a root out of this equation and we got that x minus 2 times square root of 3 equals to 0. We added 2 times square root of 3 to this equation and we got that x equals to 2 times square root of 3. So here we can write down that x equals to 2 times square root of 3. Here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. Now we can easily find out the area of quadrilateral ABCD. Quadrilateral ABCD consists of two triangles, triangle ADB and triangle DBC. Therefore, the area of quadrilateral ABCD will be equal to the sum of the areas of those two triangles. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. So in order to find out the area of triangle DBC, we draw perpendicular from point D to AB. We define this point as point S. In triangle DAS, we can say that sinus 30 degrees equals to, here it is h over 2 times square root of 3. Triangle ADS sinus 40 degrees equals to h over 2 times square root of 3. We multiply this equation by 2 times square root of 3 and we got that h equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we got that h equals to square root of 3 units, h equals to square root of 3 units, and the area of triangle ADB will be equal to the base of the triangle that is AB times the height over 2. The area of triangle ADB equals to the base that is AB times the height to the base that is h over 2. AB is 4 units and we found out that h equals to square root of 3. So AB times h is 4 times square root of 3, all divided by 2. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units, and the only thing that is left to do is to find out the area of triangle DBC. We will find out the area of triangle DBC according to a new formula, according to a special formula. First of all, we will find out the semi-perimeter of triangle DBC. The semi-perimeter of any triangle is equal to the perimeter of the triangle over 2. The perimeter of the triangle DBC is A plus B plus C, and if we define the perimeter by 2, we will get the semi-perimeter. The semi-perimeter is S, is the abbreviation for semi-perimeter. So the semi-perimeter S equals to A, that is 2 units, plus B, that is also 2 units, and C is 2 times square root of 3. 2 plus 2 is 4, plus 2 times square root of 3 over 2, and 4 over 2 is 2, and 2 times square root of 3 over 2 equals to square root of 3. So we found out that the semi-perimeter of triangle DBC is 2 plus square root of 3 units, and the formula for the area of triangle DBC is equal to the square root of S times S minus A times S minus B times S minus C, when S is the semi-perimeter of the triangle and A, B, and C are the length of triangles, the lengths of triangle DBC. We found out that S equals to 2 plus square root of 3, and S minus A is 2 plus square root of 3 minus 2 is square root of 3. S minus B is also square root of 3 because A equals to B, and S minus C is 2 plus square root of 3 minus 2 times square root of 3, that is actually equals to 2 minus square root of 3, and here square root of 3 times square root of 3 is 3, and here 2 plus square root of 3 times 2 minus square root of 3. We used the algebraic identity that A plus B times A minus B equals to A square minus B square. Here A is 2 and B is square root of 3 square. And A square is 2 square, 2 square is 4, and square root of 3 square is square root of 3 square, that is actually 3, and 4 minus 3 is 1, and 1 minus 3, 1 times 3 is 3. So in conclusion, we found out that the area of triangle DBC equals to square root of 3 square units, and the area of triangle ADB is 2 times square root of 3 units, and the area of quadrilateral ABCD equals to the area of triangle DBC plus the area of triangle ABD. The area of triangle DBC equals to square root of 3 units, and the area of triangle ABD equals to 2 times square root of 3 units, and the area of quadrilateral ABCD equals to square root of 3 units plus 2 times square root of 3 units. That is to say, the area of quadrilateral ABCD equals to 3 times square root of 3 units. So in terms of numbers, it equals to 5.196 square units. Okay, so in both methods we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 units, or in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.